Hey folks, I hope you had a wonderful weekend. If you remember at the end of last week, we were looking at these prisms, right? And our notes look like this. I want you to go find those notes. Um, I know on Friday we did a little bit different stuff, in class, and I'm looking over there at the notes. They're still up on the whiteboard up front. So we did stuff like plane symmetry, line symmetry. We did cross-sectional cuts. So we took a little break. We did this stuff on Thursday. Try to find this information right here, and let's add a little bit of stuff. Okay, so when we look at these prisms, and if I do a unroll, it's called unroll surface. Okay, it's going to take this three-dimensional object and take all of its sides, faces, and just lay them flat right down on the surface down here. Okay, so check this out. If I do unroll surface and I say explode, no, that means it's going to keep kind of the sides together as much as possible, almost like peeling a banana. It's not going to tear off one side of the banana. It's going to leave it down and kind of flattened out. So check this out. If I select this object, this prism, and I hit enter, it unrolls all the sides. Now, what are we looking at? Well, it would help if I could turn off the purple prism, and we could just look at this surface right down here. These sides right here are the lateral faces, and then the bases are over here and here. There's two bases. So, it doesn't kind of look like that though. It looks like, yeah, I think that's right. I think it is a little tough tough to see. Let me do a Control Z until we get rid of that, and we'll try to explode it. Okay, so if I go unroll surface again, that didn't look quite right, did it? Unroll surface, okay, and this time I'm going to explode all the sides. Now, oops, I forgot to select my object. Okay, there we go. So now this I think will be a little bit better. Okay, so let me see if I can slide this over. Yeah, there we go. There we go. Okay, so and I'm going to move this guy out of the way. Hold on one second, everybody. I got to remember how to do that. Oh, here it is right here. I want that guy right there. Okay, so I'm going to move this out of the way. Now look, there's 1, 2, 3, 4 basic kind of rectangles. You know, when you look at the sides, here's the front face, here's the side face. Aren't those all rectangles, right? If we go all the way around, there's another rectangle right there. Well, when you look at it this way, 1, 2, 3, 4. There's the 4 rectangular sides, if you will. Okay, the lateral area, and I'm gonna grab them and I'm gonna stick them right next to each other. Okay, so there's no empty space. So these are this is my lateral area right here. Right now, I want you to notice something. Do you see this dimension right there? That's the height of the prism. That's this height right over here. And then if you add up each one of these little edges that I'm pointing to right now, let me see here. Let's zoom in on this. If I add up each one of these little edges, that's the perimeter of the base. That's this edge right here, this edge right back here. I guess I could rotate it around. I'll just point to kind of that back edge right down there and this edge right over here, right? That's called the perimeter of the base, and then this is the height of the object. That's the lateral area. So I want you to come back to your notes, and let's add that into the left column over here, just as a reminder. LA equals perimeter times the height. Now, in order to get the surface area, we need to add these two little objects. What are these two little objects right here? These guys are the bases, right? So, look, you know, I hope I'm making this clear that if you want the surface area, you want every single one of the faces, not just the sides. It's like if this was a box of cereal, you might grab the lateral area. You generally don't grab the box of cereal on the top and the bottom, the bases. You grab by the lateral area. But the surface area would be the lateral area plus two bases. Now, what's going to be different down here? Well, let's just jump down to the surface area for a second. These guys only have one base. So the surface area is going to be the lateral area plus one base. There aren't two bases, there's just one base. Now the lateral area is a different formula. And I hope it makes sense that it's a different formula, because when you look at each one of the faces, they're triangles. They're not rectangles. Now you might say, well, these aren't rectangles with the cylinder. Well, let's do a cylinder real quick, okay? So let me do a new little sketch here. Now I don't want to save those. And yeah, we'll do just a basic little small figure in inches, and I want the cylinder now. Okay, so we're gonna make a circle, and then we're gonna stretch a circle up a ways, and then what we're gonna do is we're gonna look at it instead of like a wireframe, we're gonna look at it in a kind of a ghosted way, so we can kind of see through the whole thing if we wanted to. All right, now I want to unroll this thing. Unroll surface. Okay, so I'm gonna, yeah, we'll explode it. Okay, so I go enter. Here it goes. Check this out. Look at that. Let me let's change this guy so he's not visible. And oh my gosh, look at that. The sides, that's the lateral area right there. It's a rectangle. You know what this is right here? It's the perimeter of the base. It's the circumference of the circle. Okay, so if I was to unroll this thing, the circumference of the base is this dimension right there. It'd be so cool if I could animate this thing and let it roll right along that edge. And then what's up with this dimension? Well, that's the height. Like if I was better at this gumball stuff, there's a way to rotate this. Oh no, I'm rotating the wrong thing. Hold on one sec here. Let me grab the right thing here. And if I rotated this guy, oh boy. See, I'm not, oh, that's stretching it. Never mind. See, I'm not great with the gumball thing. There's a way to rotate. I could rotate it, lay it flat down. This is the height of the cylinder, and this is the perimeter of the base. So it's still perimeter of the base times the height. Now, the circumference is the perimeter. Now, these guys, though, oh my goodness. Okay, so let's see if I can select all this stuff and just delete it. Okay, and let's go over to a pyramid. Here we go. Okay, so ooh. Pentagon. Uh-oh. Do we want it to be a pentagonal base? We could. They might do that to us. Let's make it a little bit easier. Let's make it have 4 sides. Okay. And so here we go. I'm gonna make. Let's see. How should we do this? Let's go like this. Here's the base. Okay. Now we need to get out of perspective so we can see this a little bit better. Oh, here we go. I could just drag it straight up. Okay. Now let's see here. Let's see how this looks. Ooh, look at my cool pyramid, right? Now, if I unroll this surface, aren't we going to have a triangle here, triangle there, a triangle over here, and then there's one more triangle on this side? We're going to have 4 triangles. Let's see what it looks like. Unroll is the same thing as find the net. Okay, usually nets are not exploded. They're usually kind of attached to each other, but we're going to explode it so we can see all the different faces. Okay, here they go. Oh, look at that. Oh yeah, I'm gonna put it on the purple layer, hide that, and then let's zoom. Oh my, look at this, beautiful. Now this square is kind of in a weird orientation. It's like, you know, kind of like with the way they draw rhombuses. I could take that and rotate it down so it's just a basic square, I suppose. Let's see if I can do that. Like I said, I'm not, oh geez. That's what I was afraid of. There's a way. Here we go, like this one. No, that's not it. I forget how to rotate. Is it this guy? No, I want that guy right there. Oh, no, that just moves it. Ah, man, I'm sorry for wasting your time. Okay, anyways, you can see they're triangles. So, you know, each one of the triangles is 1/2 the base times the height. And the height, ooh, let me turn that on again. The height is not the height of the prism. It's this... let's zoom in on this guy. It's like that purple line right there. I hope you can see that on your screen. That's called the slant height. Now, sometimes people will call it the lateral height, and that's why they call it like a lowercase l. So we got to put a slant height on this thing. And my pyramid is not a regular base pyramid. So each one of these slant heights that I'm going to draw, well, 2 of them are going to be different in length. So the one I drew there and the one I'm drawing now would have different lengths because of the way the base is set up. But this base over here being a square, this slant height right here is the same as that slant height right over there. So I'm going to pretend like this is a square. Okay, so I'm going to label it as a square base, and that'll make it a little bit easier. I hope you're picking up on what I'm putting down. This thing right here is called the lateral height. Lateral height. And to abbreviate it, we use a lowercase l. And you'll hear me call it a slant height because it's slanted. It's easier than saying the lateral height. So slant height. Does the cone have a slant height? It absolutely does. It's going to be like this thing right here that I'm trying to highlight in red. So that's our slant height. And then the lateral area is 1/2. That 1/2 comes from the fact that it's a triangular shape. You might say, well, these aren't triangular shapes over here. No, not exactly, but it's still the same formula. So 1/2, the slant height times the perimeter of the base. So if we had the perimeter of the base, I'll just put down 1/2 L slant height times perimeter. I guess I'll put down P right here, okay? All right, so there's my lateral height. 1/2 slant height times the perimeter of the base. It's a little different than perimeter times height because the height, there's only one height over here. It's this thing right here, that's the height. You might say there's only one height over here as well. Well, no, the height of the prism, or the pyramid, the pyramid, goes right to the center of the base. That's actually the height, and it's not part of either one of these formulas right now. So they're gonna draw in a height to make us use Pythagorean theorem today. That's the height, right? And then this would be the radius. So we're gonna have to use, some Pythagorean theorem to figure out, what the slant height is. That's really what we need to know, all right? Hey, thanks for watching my video, putting down some notes. We're gonna try a couple of homework problems together in my second video.